So we're doing a tutorial on the kinematics that we've done briefly at Papagati, because most of the times we are doing kinematics. So this is an example from last week that I think I left for you guys to do, and which when I saw the answers they were okay. So a motorcyclist heading east through a small Chipata city accelerates at a constant 4 meters per second squared after he leaves the city limits. At time t equals 0, he is 5 meters east of the signpost moving east at 15 meters per second. A, find the position and the velocity at time t equals 2 seconds. B, where is he when the velocity is 25 meters per second? Tandu, you have a question?
Yes, sir.
Tandu, yes.
Is it just me or on your calculations B is somehow wrong?
Which B?
B. Where there. Okay, scroll down a little bit.
I'm answering kind there, then that's when you can know if I'm wrong or right. Definitely.
I saw the instead of 8, when you're supposed to use 4.
Or there? Yeah.
Yes, sir.
But all the same, it's just the two there that have messed up. Haven't you seen?
I have.
The answer is very accurate. So by ukwimi okuboko mwemya bwangu sana.
Awe, na chiduba fesa.
Okay. I know you are very accurate. There is like a mess up. So A, find the position and velocity at time t equals 0. B, Tandio is very accurate. There's a mistake in one of the solutions. So B, where is he when the velocity is 25 meters per second? So the solution, will correct where Tandio has noted. So for A, this is what I meant. The first thing is to collect the data. The acceleration is 4 meters per second squared. The initial is 5 meters. The initial position is 5 meters. The initial velocity is 15 meters per second. Then in A, we've been told that the time is 2 seconds. So we find velocity and position when the time is 2 seconds. This is what I meant by we can write them side by side. So for the equation to use, we use the first one. Why we use the equation that has all these ones which have been given, except the one we're looking for. So we just have to know how to change the subjects of the formula. But this one, we use the first linear equation. So V equals V naught plus AT. V naught is 15. How did we know which one was V naught and which one was X naught? X naught is the position when time is 0. V naught is the velocity when time is 0. So when you work this one out, you say 15 plus 4 times 2. So 15 plus 8 is 23. So this is what we should have done then. And the beauty is that you actually did this that time back. So you actually did this time back. And then this one is position x naught plus v naught t plus 80 squared over 2. There's that equation also. So we just substitute. The initial position is 5 plus 15 times 2 plus 4 times 2 squared of all of this over 2. So this is 5 plus 30 plus 8. X equals 43 meters. If you can see, I'm putting the east of the signpost. I put the east there. Even if you don't put the east, it's very accurate. Then for the B, this is why you have to make that correction that Tandio has noted. So for B, you say V squared equals V naught squared plus 2A, open brackets, X minus X naught. We're looking for X. Where is the vehicle when the velocity is 25 meters per second? So we'll square this one, 25 squared equals 15 squared plus 2. This should be times 4. This should be times 4, as our friend said. Open brackets, x minus 5, close brackets. So this is 625 equals 225 plus 8. Open brackets, x minus 5, close bracket. 400 equals, upon the substitute formula, equals 8x minus 40. When the 40 crosses, it becomes plus 40. Then when you have that plus 40, you have a 440. Then we divide them by 8, we will get 55. Are there any questions here on how to do a question like this? So we collect the data and see which equation is suitable, which equation has at least all the other variables except one you're looking for, so that you can find the answer. Are there any questions, guys? Guys, are there any questions? Bachibusa, you're too mute. Opomudi, are you around?
Yes, sir. They are around.
So if you don't answer like this, means there are no questions?
Yeah, it's clear.
Okay. So now this is the question immediately related. I think this is the toughest for you. Now, this is the toughest. So a car is stopped at the traffic lights. It then travels along a straight road so that its distance from the light is given by x, open bracket, time, close bracket, equals 2.40 squared minus 0.12 t to the power 3. I just pushed this one in because I realized that even when we learned the first time about the antelope and the cheetah, people didn't get this one. I felt it in my spirit. Sorry guys, but that's where and. So this should just be where x is in meters and time is in seconds. And it's what you assume. You assume SI units. So sorry, I omitted that statement where x is in meters and time is in seconds. Even if it's not given, that's what you assume. Because the meter is the SI unit for position or distance, and the what time is the SI unit for the a second is the SI unit for time. So calculate the average velocity of the car for the time interval t equals 2 seconds to t equals 10 seconds. 8 max. 8 max was very involving. B, calculate the instantaneous velocity of the car at time t equals 5 seconds. So this one also 5 max. How long after starting from rest is the car again at rest? Also 4 max. So total max 17. So now this question 17 from 100, D equal bad. So this question is very straightforward. The reason why it has some marks, I've solved it here. I've solved it here. So the first question is calculate the average velocity of the car for the time interval t equals 2 seconds to t equals 10 seconds. So the first thing is you copy the equation. X as function of time equals naturally sanga murubiro. Let's hope I haven't made mistakes. So go and go through also. This is 2.5 t squared minus 0.12 t to the power 3. So remember average velocity is x final minus x initial. over t final minus t initial. So the t initial is 2 seconds. The t final is 10 seconds. Initial time need no. Final time equal. It's not like a displacement and velocity, which you have to look at which one was mentioned later. But for this one, even if someone said during the time interval 10 seconds and 2 seconds, the smaller time, takuwa bokuya opposite muli time. It's a scalar quantity, so time is always increasing. That's why even your years, they're always increasing. Nangu ulande shana madadi, mami, ni shule kula. So those are the things. So x v equals x final minus. So to get the x initial, which you have to put here, you get this entire equation and substitute where there is t, you substitute 2. So it will be 2.4 open brackets 2 squared close brackets minus 0.12 open brackets 2 to the power 3 close brackets. So this will give us 2. We can be going through together. So this is 2 squared is 4 times 2.4. So you actually get 9.6. So 9.6 minus, when you work this one out, 2 to the power 3 is 8. So 2 to the power 3, if you are so scared, you just say 0.12 times 2 times 2 times 2 to multiply the 2 3 times. You get 0.96. So 9.6 minus 0.96 will give us 8.64 meters. That's all. So that's what it means. So if you see, I said xi equals x open brackets apapa the time to abika for 2. Apart the time to abika for 2. So that we substitute in that function to everywhere where there's t. Also, the final is 10 seconds. So you say x open brackets wabika for 10 x then equals you put 2.4 open brackets again 10 squared minus 0.12 open brackets 10 to the power 3. When you work this one out, you get 240 because akanika z, then akanika pin. So you get 240 minus 120, which is 120. So now when you work this thing, you say final, nishwasanga final, na initial na wasanga, then you say 120 minus 8.64, all of this over 10 minus 2 equals 111.36 over 8. The answer, friends, is 13.92 when you divide. That's all. So it's very involving. The second one is find the instantaneous velocity of the car at t equals 5 seconds. So to get instantaneous velocity now, you differentiate this one. D dt of this. V inst is dx dt. This is d dt open brackets 2.4 t squared minus 0.12 t to the power 3 close brackets. So then remember what we did when we were differentiating. The 2 always goes in front there. So it will be 2.4 times 2 t to the power 2 minus 1 minus 0.12 times 3 t to the power 3 minus 1. So 4.8 t ALI hapa minus 0.36 t squared. Then you substitute now the 5 because we are looking for instantaneous velocity when t is 5 seconds. So you substitute the 5. Then you're going to have 4.8 times 5 minus 0.36 times 5 squared, which will give us 24 minus 9. 24 minus 9 is a beautiful 15. That's a very beautiful answer for this question. Then the last one, it needs now for you to know some points. That's why I said At rest, the velocity is 0. At rest, when something is at rest, the velocity is what? 0. So at rest, the instantaneous velocity which you have found here is 0. So you will find this equation is 0. So you write it again. 4.8t, sorry, nashifati mbike squared na chilaba. So 4.8t minus 0.36t squared equals 0. So then you solve for t. 4.8t minus 0.36t squared equals 0. Then you factorize t out. T open brackets 4.8 minus 0.36t close bracket equals 0. So the solutions will be t equals 0 is not what you're looking for because they've told you other how long after starting from rest is the car again at rest. So starting at rest, t equals 0. So the one you're looking for is to equate this other thing, 4.8 minus 0.36t equals 0. So this crosses the equal sign. 4.8 equals 0.36t positive. Then you divide over 0.36, 0.36. So t is equal to 13.3333. Number 3 at 33 bar. So 13.33 bar seconds. So that's how you go about this one. Are there any questions, guys, on how to solve this one?
Yes.
Yes?
Sir, can you just start on top of the same question? Yes. I didn't get the first part. My network was kind of breaking.
Who is this?
Monday.
Monday.
No, Monday.
Monday.
Yes,
The
sir.
beauty is that even if the network is broken, first of all, you may still go on YouTube and see the points. So always know that because I always put these videos back on YouTube, all of them, including yesterday's. How the first part we said average velocity. Average velocity we said is final position minus initial position, which is displacement over the time interval. So to get the displacement for the x final, the final position and the initial position. So we know that the initial time is 2 seconds and the final time is 10 seconds. So what we do to get the initial position, we'll get 2 and substitute it upper. We'll put everywhere there's t, we'll put 2 seconds so that we get the initial position. That's why we said x initial is equal to x, where the function is 2 now there, equals 2.4. Then where there was t, we'll put 2 squared, and we're doing whatever it is we're doing to the t, minus 0.12, you substitute 2 to the power 3, close bracket. So this gave us 9.6 minus 0.96, which is 8.64. So this thing is the case. Then for the final, you do again the same. You substitute now the 10, because that's the final time. So you substitute 10. Everywhere there's t, you put 10. So 10 squared, 2.4 times 10 squared, minus 0.12 times 10 to the power 3. Then you get 240 minus 120, which is 120. Then now, you substitute back up, where it says the average velocity is final position minus initial position over final time minus initial time. So it's 120 minus 8.64. All of this over 10 minus 2, which is the time interval. So it's 111.36 over 8, which is 13.92. Even if the network it's not bad, like network if you win. Naka kosa feka question, never to engalanda fe. Naka kali too unique.
Nakakosa zaka.
But when you see what we've done, you will see that it's very straightforward. That's why these questions like this, because there's so much to do, they get a lot of marks. That's the way it is. Naomi, you have something to say? Moffat. First of all, let's have Moffat. Moffat, say something. Moffat, sir. Moffat. Kapata Moffat. The network is bad, eh?
Why you subtracted the 1 from the 3?
Which one? From the 3? Party
Yes,
differentiation.
B. M.
Party B. If Amaruz, you remember Amaruz party power? You say, is this one you're looking at?
Yes, sir.
The rules for calculus are that if you have t to the power 2, the 2 goes in front, then this one you subtract 1. That's why I said 2 minus 1, if you remember. Therefore,
Yes, sir.
2.4 times 2, t to the power 2 minus 1. Then 0.12 times the 3 comes in front, then again 3 minus 1. Emma rules, power rules. This should be a lesson when we did the recap on calculus, you go through that.
Sure, sir, I will.
You have remembered now, eh?
I've remembered, sir.
Okay. Naomi, you don't have a question, but your mic is on. Naomi.
I want to ask.
Yes, okay, you can ask. Yeah, you can ask.
My question is, can you hear me?
The network is terrible, man.
Okay, sir. If you at least you'll be able to get somewhere. Just scroll down. I was trying to answer the first question.
Yes.
Down on your screen. Yes. Then tell me where I went wrong, because I've seen that some of my answers are wrong as compared to yours.
No. Mommy, don't you kumbika na magasana. Nasale mba murubiri wefu. So you just show me how best you did. This is a question, don't you kula mfo mwenzonga wa mwanansa and yapsana neyo. If in science that won't feel I might have made a mistake somewhere. So just show me your work, defend it academically, then I'll show you also what I was doing. Then the end, this is not a court of law where you just have to be correct. We want to learn, both of us. You teach me, I teach you some. So don't look down on your effort. You did well. Yeah. Gordon.
Yes, sir. I just want a bit of explanation on the last question.
The last
on
question.
Finding the time where you were explaining about the equation stated and how to find the time where it equals to 0. That's the point. I just want a bit of explanation.
Right. So how long after starting from rest is the car at rest again? So remember, guys, that at rest the velocity is 0, and then we have found the function of velocity, which is the instantaneous velocity. The one we found, the function was the one when we differentiated the position function, we got the velocity function. So which was the 2.4 times 2 t to the power 2 minus 1 minus 0.12 times 3 t to the power 3 minus 1. So we got 4.8 t minus 0.36 t squared. You get it? So this function, all of it, you should equate it to 0 to find time when a particle is at rest. So when the position is 0, when the body is at rest, when the velocity is 0, you have to equate this velocity function to 0. It means something is at what time? At rest. Are you getting it?
So, sir, we actually equate to the differentiated equation, not to the original equation stated.
No. Can you remember in the Fokolondolanga Waibuksha Golden? When they say a car starts from rest, what was the detail of Yalebati? It means the velocity there is 0. When something is at rest, the velocity is what is 0, not the position. Kaya panga wasabi kapa is 0 up. Nansa fayala one is 0. Kai position yena ile wafia 0 pa kwamba para pen. Are you getting it? Unless we are asked to say,
Yes, sir.
when is the car back at the origin? That's when you reason like that. But remember the word rest. You did it musogo. When you say a car is at rest and starts to move uniformly, you remember that that meant that the initial velocity of the car is actually 0. I'm sure you remember that. You don't remember, guys?
Yes, sir.
So if something is at rest,
I do.
the velocity is 0. So when they tell you find when it is at rest, it means they want you to equate the velocity function to 0.
Okay, sir.
Are you getting
I
it?
understand, sir.
Yeah, sharp.
Yes, sir. Thank you. Thank you.
Welcome. I'm not sure if you're feeling how I so because vengi am imitwe shikwasede. Naomi, you have another point.
Sorry, I just
Yes? Any other questions, guys? So that is the case on what you should have done. Caching and fair video question. The others are just for you to practice more. I'll send the answers. I'll send the answers. I love the attempt from Naomi. I love the attempt from Naomi. So the only mistake she made was that as I started differentiate, she didn't use the original function. You use the function just the way it is when you're substituting in to get the initial position and the final position. The ones you put in your average velocity expression. So don't kubutukira kwamba differentiate hiyo. Differentiation started at the next question. Why? Because the first question just asked for average velocity. So the party point to differentiate hapa hiyo. You just do 2.4 wasitapo substitute wasanga x final. Wasitapo substitute wasanga x initial. Then you do the expression x final minus x initial over the t final minus t initial. Then muli B, emulati, find the velocity at time t what. There now, there you have to differentiate. Then C, we are told that if something is at rest, then its velocity function must be equal to 0. If something is at rest, then the velocity function must be equal to 0. So that is the reasoning. So those are, yes? Yes, sir?
Yeah, I want to ask on the same question. Now, I want to ask on the same question you are from.
Yes.
I want to ask on the same question there.
Yes. Ask.
On B.
B.
There they have asked that calculate the average, calculate the instantaneous velocity of the car at time 5 seconds.
Yes.
What if we are asked to calculate the instantaneous acceleration? We would have differentiated in the same way, or?
Yeah, if they asked us for the instantaneous acceleration, would have differentiated this function twice. It was just differentiated. It was under 4.8t
twice
0.36 squared. Then here again, we more differentiate. Acceleration is the v dt. So when you get the v, you differentiate it again to get the acceleration. Is that helpful?
Okay. So the instantaneous acceleration we differentiate twice, then the instantaneous velocity we just differentiate once.
Yes, velocity. No, as you look at the function you've been given, sir, here we've been given position function. So when you differentiate the position function, you get a velocity function. When you differentiate velocity function, you get acceleration function. Meaning, if this equation were given with the velocity, to get acceleration, we're only going to differentiate once. Number boss.
Okay.
Yes.
Okay.
So if this
Yeah,
was
now, thank you very much.
yes, to get velocity, if this was velocity, to get acceleration, we're going to differentiate once. To get position, we were going to integrate. Number that will have cap. But integrate. Na pena tuleya. Na mumbale. Tuleya padi
Okay. Now, thank you very much.
Guys, mwachola lelo Sima question tubiri. Mishta Shabipa. So here,
Basa kulina imbikunshi basa.
padi line question.
Awe, nataka kwa tumanda vat pali vya mansa abiri.
Oh, ninja manama answers. I'm trying to explain. That's now on these other ones. This one, all these questions that I've put up here are all different in the way you go about them. So that's the way it is. Question 3 and 4, you just use the same equation. Equation, you remember, which says x minus x naught over t equals v naught plus v over 2. Iremben x minus x naught over t equals v naught plus v over 2. Go to another equation. Go and look for it. It can also be written as delta x over t equals v naught plus v over 2. So guys, delta x upper ni 70. Upper na po delta x ni 80. Why? The distance of 80 meters. The 2 points are 70 meters apart. So that's delta x. Then this in terms. So mara on equation ni moine. Apa ukarasanga po time. Apa first warasanga po speed na then na acceleration. So hii equation wala ibonfefe kusangira mo speed. Then the other one, yeah, acceleration, you go back to the first equation of motion, which is v equals v naught plus at. So go and try it. Aka next, there's just a lot of reason in Valemu Pepeka. You just have to solve it a bit. I promise the answers will come. I'll leave this pending for some time and I'll be solving these answers for you. I'm avoiding calculus. Akaka Pepeka nakalaruka na ka quadratic. Aka makafida like quadratic na formula yonsemo abikamu. So that's the thing. Are there any questions, guys? Any points? I want you to be the last ones to say something. Yes, guys. So, Apa, on the chess, since you're not saying anything, you want to finish that? On the chess, this person is moved. Yes,
Sir.
Douglas.
Just repeat on the formula you said.
Delta x over t equals v naught plus v over 2. Okay. So here pepekane ngomlepeka kabola. This person limit ni 10 meters per second. Ena auma 15. So meaning the 10 is not going to be used. Because that's a struggle with a lot of students. Value ngai monafya muri question. No net sungu chila chonse. Kwamba kufana pa kubika 10. So sasa ngomuntu asabika 15 to the power 10. Amba no kusanga. So the 10 is not going to be used. So this person is moving at 15. Mambale? Constant. So that is to accelerate. So if someone is not accelerating, ida displacement function here delta x equals v naught t plus at squared over 2 kulokuba acceleration kuba 0 ndakayi. When someone is moving at a constant speed, then the acceleration is 0. That's how it is. Then uyu muntu umbi aletusha lelo lelaba milandu, meaning his initial velocity is 0. So you make two displacement equations for them, and then for them to catch up, you equate those two equations, and they help you to find the time. They help you to find the time. So that's the reasoning that you put there. Then EMB, you're slowing down. So if something is slowing down, you definitely know that the acceleration is negative. So work it out. Nei and slowing down. I think in Imoin. That's one question 5. I'm 5 years where we say lembulamo imukshibidi. That was the reasoning. So go and do it. Then the other one, this one is velocity time graph. So draw. The shape of your velocity time graph must be a trapezium. If it's not a trapezium, you're doing something wrong. Let's continue to practice, guys, like this. It's enjoyable, but it's helpful for us so that when I'm